This is the Rigaku SmartLab, and today I'm going to show you it in the point source 2D detector configuration. So the best way to do that is to open up the cabinet and now we'll look inside. So the SmartLab system that we have has an option of a 1D detector or a 2D detector, and we also have a 0D or point detector or a scintillation counter as well. Now in this configuration we're using the 2D detector, and you can see here it's got a window, and this window is basically similar to the technology that's in your mobile phone in the sense that it's got a two-dimensional image can be recorded onto the detector. So you can think of it a bit like a movie camera. So if we look at some data that's been collected from the system, you can see we see diffraction rings in 2D space. So we get this whole curve, or part of this curve, which constitutes the cone when it's reconstituted in 360 degrees. What this can be converted into is a standard diffraction plot, and that's just by integrating the intensities along that curve. So that curve then translates into intensities with 2 theta. So to do this with this system, we have our X-ray tube, just like normal, running copper K alpha radiation. That X-ray tube goes into this CBO optic, and to sort of operate with the Rigaku system, a lot of the optics that come off the CBO are reliant on a parallel beam coming off the CBO optic. That parallel beam then goes into the CBOF, and at this point here it's a line source, so it starts as a line in the X-ray tube, goes through here as a line source through the CBO. But when it hits the CBOF, this is a polycap type optic, so lots and lots of glass capillaries all bundled together, and that means that we are able to convert that line source into a point source on the exit of the polycap or the CBOF. We then take that point source and we then can collimate its size again using a collimating tube. These are just single pinhole collimators, so they just really tidy the tubes, tidy the X-ray size at the tip of the tube here. You can get double pinhole, which you can use for alignment purposes as well. Then we have our sample, and in this case we've got a beam size which is about 100 microns, and on our sample we actually have a very small target area, and this stage here is motorized in X and Y and in Z, and that allows us to program the system to measure particular points on the sample surfaces. And we do that, we can do that for either one sample, or in this case we've got 4 different samples being measured, one after the other. From there we then have the diffraction pattern that goes into the detector. So this is on our diffraction side of our diffractometer, and depending on the distance between the sample and the detector will govern the angular resolution that the detector front face can resolve. So at the current position, which is as close to the sample as we can get it, then the detector front window sees about 15 degrees in 2 theta. Okay, so that's pretty much everything to do with the SmartLab when running in a 2D operational mode with a point source.